All right. Welcome to day 48 of 100 days of data structures and algorithm. So, I don't know. Is something wrong with my microphone? I'm not so sure about this, but it seems my microphone is picking really high, which is strange because I did not touch the microphone. Hey, nice Shub is in the chat. Or Shub or Shub, I don't know. Anyways, thank you for coming in. I really appreciate your presence, and yeah, let's keep going. So I've got my stress ball here. Oh god. Anyways, let's keep that aside. I'm not sure how I'm sounding in this stream because I can see my mic is picking really high. But if it's good, please can someone indicate that? Otherwise, I can use my phone here to check if my microphone sounds good. But if it's good, please can someone indicate that? I don't know. Is something wrong with my microphone? Okay, it's good. It's good. I don't know why OBS is telling me it is speaking so high. Anyways, so today I'm going to share some tips and tricks to solve sliding window problems, which is, I just discovered this, right? Because most sliding window problems are really how do you call it, two pointers problems, right? And it is very, it is very strange that we have a separate algorithm for, two pointers and then another one for sliding window, but both of them are just like intertwined, right? Because when you know two pointers, essentially what you do is also sliding window, right? But then for sliding window, right, we either try to get a subset of a certain value, or a subset within a string, or a subset within an array, right? So sliding window essentially involve looking for a subset from a larger set, right? So let's say, for instance, we have a string, a string like this. Let's say A, B, C, D, right? And then we want to, search for the longest substring, right? The longest substring without repeating characters, right? In that case, we can use a sliding window, right? I'll call a sliding window SL, right? We can use a sliding window to solve this problem. I'll put it this way. We can use a sliding window to solve a problem like this. I'll put SL. And in another case, let's say we are looking for a particular string, right, as part of a larger string. Let's say I have sad but not sad, right? This is a string, right? Sad but not sad is a string, and we want to look for, let's say, the word but, right? Let's say we want to find whether but is part of this string here, right? For us to look for but in this string, we still need to use the sliding window algorithm. So it's either going to be, so for us to do that, we'll either have, a fixed window, right, which is going to be the size of our string here, which is the string we are looking for, right? And then we'll search we'll search for this string, right, looking at the same amount of string, right, in the larger string here, in the larger set. I'll call this a larger set. So essentially we are going to look at three characters at a time, right? 3 characters at a time, and the each end of these characters will represent our window, right? Will represent the end of our window, and the ends of the window is essentially the left and the right pointer, right? So when we are looking, for an item in the sliding window, we always use a left and a right pointer starting at the same position. Now one thing will happen, right? When they start at the same position, the right pointer is going to increase, right? It's going to increase linearly, or it's going to increase with constant value, right? So in every iteration, our right pointer is going to increase by 1, right? So let me just do it this way. Let's say we are looking for the word but. We are looking for the word but in this string here, right? In this string here, we are looking for okay, let's say we are looking for not, right? N-O-T, right? We are looking for N-O-T in this string here, sad but not sad, right? So for us to look for this, right, we essentially need to use a sliding window, and we will look for the same. We'll compare the values in this larger string here against this string, but looking at the same amount of string that we have in the I'll call this the lookup string, right? This is the string we are looking for. So we are going to take, again, we are going to look at 3 characters at a time, because we have 1, 2, 3 characters here, right? So this is going to be 3 characters at a time. We'll look at this, right? And then we'll look at another 3 characters. Again, we can look from this point to this point here, right? So here to here, right? 3 characters at a time, and then we can go from here all the way to this point, and then from this point all the way, and so on, right? Now, so for us to do that, we would need 2 pointers, right? We will need a left and a right pointer starting at the same position. They will both start from the beginning of the string, or our larger string, right? Now we will then move the right pointer through the string towards the end, right? Now for us to do that, we only need to move this we keep increasing this string, right? Whenever we increase the the left and right pointer, the right pointer towards the right, or just in other words, we are just increasing the right pointer through the larger string. We will then compare the values, right? We will then compare the values against this string here to see whether where we are at, right, where our right pointer is, where our left pointer is towards the right pointer, right? Towards the right pointer, we have a valid string, right, that is equal to our input string here. Now, if this example is confusing, let me use another example. Let's say we are looking for sorry, okay. Let's say we are looking for let's say we are given an array, right? This array is, I'll call this array A. A is equal to A is going to be equal to, let's say 3, 5, 6, 8, right? And we want two elements in this array, or 2 contiguous elements, which means they have to be one after the other, arranged in the same array, right? They have to be one after the other. We want 2 items from this array such that when we add them up, they are equal to the possible maximum we can have, right? We don't know the maximum, but we know that we want 2 items, right? So we can represent this by k. Now in this case here, right? When we are told to find you know um a certain amount, right, of sub item as part of a larger array or a string, right? When we are told to find that, we know we'll have a fixed window, right? A fixed window, the size of our window is simply going to be equal to the input that we are given, which is this k here. So our window has to be 2 at all time, which also means that the amount of items we have in the window has to be equal to 2. Actually, I made a note about sliding window, which I'm going to share with you on GitHub. Basically, so here's a trick. So let's say we have sliding window for a fixed size, right? Sliding window for a fixed amount of k items. So for us to do this, essentially we need to initialize the window sum or initialize the window sum or property for the first window k, for the first window of size k, right? So which means for us to find the 2 items in this array such that when they are added up we get the possible maximum value, right? We simply need to find a fixed, we first of all need to find the sum of the first k element. The first k element is simply this and that, right? So from the beginning to the second item, which is going to be 2 items, right? So we first of all find the total here, which is going to be equal to 8, right? This is 8. So after finding 8, we then start sliding our window through the array. So slide the window by adding the next element and removing the first element from the previous window. So we first of all, we found our window. This is the window here, right? Again, the window is simply going to be here from here to this part here, right? From this point to this point here. Now we found the total within that window. So what we do next is slide the window. Now watch what I'll do. When I slide this window across to this side, right, you can see the first item was removed from the window and there is an introduction of a new item, right? So this is the first item and this is the new item we introduced into the window. Now remember, the window will always contain 2 items, right? And the window is of fixed size. So when there is a problem for finding a fixed size of a fixed amount of elements, right? Let's say you're asked to find 2 items in a string that 2 items in an array such that they add up to a certain value, or such that they add up to anything at all, right? So in that case, right, what we need to do is to first of all find a fixed size of items, right? A fixed total first of all of the items in the array. So by just taking the first and the second, in this case our given window is of size 2, right, which is this k here. So what we do next is, after finding the total, we begin to slide our window across, right? So we begin to slide the window like this. So we slide by removing the first item in the array and introducing a new item, right? So every time we do that, every time we slide the window across, we remove the previous value from the window and introduce a new value, right, which is this note that I made here. So and then you just track the results by getting the maximum or minimum if based on the question. So let me show you how to do that, right? So I'll come here and say, let's define a function. I'll call this maximum. Okay, so I already have it here, but I'll need to explain this properly, because this solution works fine, right? It is good, but there is another way. There's no other way. But what I meant to say is, I would like to explain this, step by step, and make it clear for you guys to understand. So let's say this is the maximum subarray sum. So basically this question is asking us to find two items or k items, right, in an array such that they add up to the maximum possible we can have in the array, right? So this is an array and we are looking for a maximum, right? So first of all, we need to initialize the first maximum, which is going to be our first window. So I'll use the other explanation I made here with the window, finding the first total in the window. By I'll replace every variable name here to a much simpler one, right? So let's say we are finding I'll call this max sub array sum, right? This is simply going to be equal, so this is going to take an array, right? I'll call this okay, so I'll call this nums is going to be an array, and we'll need sorry, we don't use array here, we use list in Python. So I'll say this is going to be a list, right? So let me import this, and then we'll need a k, which is going to be, I'll call this window size, right? Window size, or let me just represent it with k, since I'm going to be typing this out. But essentially what k is the size of the window, right? So here's what we need to do. We first of all need to initialize the largest, the first total, the total of the first k elements, right? So we'll say the maximum sum, right? Max sum, I'll call this max sum, right, is going to be equal to the first k elements, right? So here's how you do it. First of all, you'll find the maximum of the first k element by just using an array slicing. So you use the slicing method, or you can even use let's say a for loop, right? You can use list comprehension to get that value, but I'm just going to use the sum here, right? Sum is simply going to be equal to the first k element. So I'll just say nums the first k element, right? So slice this. So this will slice every item, right, from the beginning up to 1 minus k, right? So let me show you what I meant by that. So let's say if we had an array, I'll copy this array here, and I want the first 3 elements in this array, right? I'll call this nums and set it to equal to this array, and I want the first 3 elements in this array. I'll simply do nums, right? Since I know how many items I want from the array, I'll use the slicing method, right? So the slicing method is simply just using the square bracket and putting this column in it, right? If I did this will copy the entire array, right? So let me print this out for you to see. You can see I copied every item in the array. But let's say I want to copy the first 5 items, right? I can put 5 here, but what will happen is the array will copy the first 4 items, right? So let's run this and see. You can see we copied up to index 5, right? So let's see, this is going to contain 5 items, but when you start counting from 0, it will stop at index 4, right? Meaning we are copying the first 5 items. Yes, that's good. But let's say we did something like this. We want to copy up to index 2 and pass 2 like this, right? We'll have 2 items, but it will not include the item at index 2, but instead it will include the item at index 1, right? So let's run this again. You can see we have 0 and 1, but it's 2 items, it's fine, right? So in the case where we want to copy the first 5 items, we simply need to copy it like this by passing the 5 in it, but you just have to have it in mind that this is not copying the item at the 5th index. It's going to copy up to the 4th index, right? So by just saying like this, I'll just print this here. Now you can see the item at index 4 is going to be this 4 here. So let me prove that to you by just print nums at index 4. So sorry, index 4 like this, right? Now you can see we have 4, which is equal to this 4 here. So we'll use this method of slicing the array, right? We'll first of all slice our array. I'll keep the nums there, right? We'll slice our array and find the sum at this point, right? So this is a beauty method that I'm using here to find the current sum. Now all we need to do next is to just oh, somebody is saying hi in the hello, welcome to the stream. All right, so let's go carry on. So I'll say for, so I want to iterate through the array by removing the previous value, right? Previous value, and adding a new value, right? So here's what we need to do. I'll simply say for I in range, the length of the number, right? Nums. Now there's a catch here, right? Since we are looking for, a certain amount, right? Since our window has a fixed size, right? We need to respect that. Otherwise, we'll iterate up to the end, right? Up to the end of the array, and our window will fall out of range. So we want to keep our window within the array, right? Within the boundaries of the array. Meaning, when we move our window like this, we only want to move it based on its size, right? So we want to move it from here to here, and then from here to here, and then we stop our iteration. Now you can see our left pointer, right? Our left pointer is at this position here. I'll call each end of the array a left and right pointer, right? So we have our left pointer here and our right pointer here. Now our right pointer, reaches the end of the array, which is good. But in this case, if we how do I explain this? Let's say we have the borders of our window, right? These borders will help us. There's a word I want to use. Okay, we are sliding this border across the array, right? Which means we don't really have a left and right pointer at this point, right? It's a sliding window problem, which also, like I explained, it's going to involve some, pointers. But in this case, we don't really need the pointers. We just need to know the size of our window, right? The size of the sub array that we want to, check for a condition, right? So since our window is of size 2, right, we only want to increment the window each time so that we always have two items in the array or in the sub array, right? 2 items in our window. So meaning when we are looping through this array, when we subtract a value, right, let's say in the first iteration, since we already know the size of our window, right, we had 8 already. So here's what we need to do next. We simply need to remove 8. We simply need to remove from 8, right, the previous value, right? We'll do -3 plus 5, right? So we need to do this. When we shift our window this way, we remove a previous value, and then we insert a new value, right? So in this case, when we are doing that, right, we only want to remove values up to this point, right, up to the last item here, and we also want we want to add value up to the last item and remove values up to the last item but 1, right? We want to remove values up to this point. Not but 1, but the size of the array. So we want to only remove values up to this point, here, right? Because we can't move whenever we remove an item from the window, we introduce a new item, right? So we only want to remove up to this point here, right? We want to remove up to this point, right? We can't remove this place because we don't have anything else here to add to the window, right? So that's what I was actually struggling to explain. So let me go over this again. So we have a fixed size of window, right, which is equal to k. Now we want to add an item to the window and remove an item from the window, right? To do that, obviously we'll need a loop, right? We'll need something to iterate the array, right, and move our window across the array. So for us to move our window across the array, we need to remove an item and add a new item. So when we remove an item from the window, it basically means we are shifting the window, right? We are removing this from the window. But when we shift the window, we introduce a new item to the window, right? So we can only remove k items from the window, right? We can only remove up to so let's say in this case we are removing up to this point, right? Because we can't remove this, because whenever we remove, we introduce, but when we remove this, right, we don't have anything else to add to the window. So we stop at this point, right? We stop we stop at this point here. But what does this point mean? What calculation can we perform to be able to get to this point? So in order for us to do this, we simply need to know, the length of this array. I'll say length of A, right? The length of the A array minus K, right? Minus K here, right? Minus K. So K, length of A would be 4, right? Length of A would be 4 minus 2, right? This is going to be 2. So we know we will iterate up to 2, right? Up to 2. And we know when we are using the range function to iterate through an array, it always stops at 1 minus the value, right? So let's say we want to iterate up to 2, so it will start from 0 and stop at 1. It will not include 2 in the array. So using this range function will be good. So that's another trick to know. So we simply need to iterate the length of the array, right, minus K, right, minus K, and then we begin to remove and add items to our window. So how do we remove an item from the window? First of all, there's a straightforward way to do that, right? By simply, so we need a copy of this maximum sum. I'll call it our inner sum, which is what we use to add and remove from. So I'll call this copy sum, right? This copy sum is what we'll remove and add items to, so that we'll have the maximum sum in place to find the maximum in the array. So this is what I'll do. I'll say copy sum will simply be, so we'll remove the previous value, right? We'll remove the previous value will simply be, how do we remove? So we'll say I'll just do copy sum, right, minus equal, the previous value will be the value at I, right, which is here, this first value here, this first value, and then the new value we are introducing into the array will be this 6 here. And what does this, how do we get this 6 here? Basically, to get this 6, we know the size of our window is going to be 2, right? So to get to 6, we simply need to add I, which is 0 for now, to 6, to K, right? I to K, so that we can get to 6 here, right? We need to add I to get to 6. So I to K will simply be 2, right? I plus k will be equal to 2, and we know item at index 2 is this 6 here. So that's what we need to do. I'll just move this here. I'll say let's remove the first item. The first item removal will be nums at I, right? We remove this, and then we'll say copy sum, right, plus equal the new item we want to add to the array. So it'll simply be equal to I plus k, like this. Now after doing this, we'll then calculate, we'll then compare the maximum. So the maximum sum will simply be equal to the maximum between the maximum sum, right? The maximum sum, sorry, the maximum, not max sum. This is the built-in method for finding a maximum sum and the copy sum, right? So this is how we'll find the correct maximum. Let me just run this function, right? I'll say max subarray sum. I'll use this example, right, so that we know whether this is correct or not. So let's find the maximum sum of two contiguous items in this array. So I'll say I'll remove all of this here. So the first one will be here, right? The first one will be here. So in the first window we'll have 8, right? And then when we move the window across, when we move the window to this side, this will be equal to 11. And then when we slide the window again to this place, right, when we slide it to this place, this will be equal to 14. This will be equal to 14. So we have 3 possible pairs of 2 items in this array, right, from this point to this point. So the possible maximum we can have here is 14, right? I'll use this array to find the maximum and return the maximum. So instead of using these nums, I'll just say this is going to be equal to I think it's 3, 5, 6, 8, right? And then we want our k, the size of our window, to be equal to 2, like this. So let's run this. We are not printing anything, we are not returning anything. So let's say come on, let's say return max sum, right? The maximum sum will be returned here, and I'll need to print this function, or I'll just set this to result. Now let me just print it. Let me just print it instead. Print this, right? Let's print this and see. Now you can see the answer is 14, which is what we calculated initially. So that's the first tip for a sliding window problem. Now so if we have a fixed size of item, right, we are looking for a fixed size of a sub array or substring, right? We need to simply do something like this. We initialize a window, we sum up the first k property, or the first fixed amount of items, right? Initialize the window sum or properties for the first window of size k, right? Slide the window by hiding the next element and removing the first element of the previous window, right? So the first element of the previous window will be removed. The last element, or a new element, will then be introduced into our window, right? So now let's say this time around we don't have any fixed size, right? the size is a variable, like it's not fixed, it could be anything, right? So how do we do that? Well, in this case we'll use a right and left pointer, right? So use a right and left pointer to expand the window, right? And then use the left pointer to contract the window when a condition is violated, right? Update the result whenever the condition is satisfied. So how do we do this? Well, let's say we are looking for the longest. So I've chosen some questions, right, that these cases will be applied to. So let me show you what those questions are. So I'll first of all use this question here. I think I solved the question like that, and you'll see that this actually works for all of them. So you know what, I'll start with the easier one, although okay. So longest substring without repeating characters, right? This is a question I solved previously, but I used a method that was not really I think I just found out about a new method that I could use for this question, use for another question, and 3 sets of questions that I just chosen in the comments, right? But the solutions are not really optimal, or in other words, they are not the best solutions, but they work, right? They work, which is good to understand as a beginner, right? Like myself, in order for you to go from there and look for a much more optimized solution. So how do we do this? Well, like I said, in this when we are given a variable size of window, right? Let's say this question here, this question is asking us, given a string s, right, find the length of the longest substring without repeating character. Now, why is this this case here applicable to this question? Well, the question is asking us to find the longest substring without repeating character. Now, we don't know how long the substring would be, right? So we don't have a fixed size of window. So we need to create a left and right pointer, increase the right pointer through the string until we find a condition that a window that violates a certain condition, right? And then we contract the window, right? We begin to reduce the window by moving the left pointer towards the right to reduce the size of the window. So let me show you. So let's say we have this string here, right? A, B, C. I'll just copy this string, remove everything from this screen here, right? A, B, C, A, B, C. So here is our string, right? And then we have, the question says we should find the longest string without repeating characters. Now, we don't know the size of our window, right? We don't know how long the string will be. So it's not given. If we're told, oh, the longest string is find 3 characters, right? Find 3 characters in the string such that there is no find a substring, right? Find a substring in this string, and let me use this case. So let's say in the case where we are given a fixed size window, right? Let's say our window is going to be of size 3, right? The question would be that we should find a substring, right, which is obviously going to be a substring of this string of size 3, right, or length 3, such that the substring does not contain any duplicate. So for us to do that, we simply need to start from the beginning, right? We simply need to find the first substring in our window, and then we slide the substring through the string by just removing the previous and adding a new string, right? So we'll move this from here to here, and then from here to here, from here to here, from here to here, and so on till we reach the end of our string. But in this case, I mean, that's just an hypothesis, right? I'm not really saying the question says that, but what this question is saying is we should find a substring, right, such that there are no repeating characters, which means our substring could be one character long, right? If every character in this string was repeated, then the longest substring within this string would be 1. If we had a string filled with a, right, it's like this, right? The longest substring without repeating character will have length of 1, because it's just one character that is not going to be repeated if we chose that as our substring, right? So, but in this case, which also means that we don't know how long it will be, right? So we then initialize our left and right pointer at the same position, right? And then we then begin to increase our right pointer through the string until we meet a string that has been repeated before. Then we just shrink we will shrink our window, right? Currently our window is going to be like this. So let me move this back again. So we initialize our left and right pointer at the same position, right? So, and then we'll begin to slide our right pointer across the string, right? And each time we slide the right pointer across the string, our window is going to be of that particular size, right? You can see our window is going to be of this size, which means, let me use this. If I can slide this across, good. Let me use this instead. So let's say our window is here, right? Our window, will have a left and right pointer at the same position. So our window is essentially going to be like this, right? It's going to be at the same position. So we'll then begin to move our right pointer through the string, right? And every time we move our right pointer through the string, our window is going to be of that size. Currently, our window will have a size of 2, right? Our window is going to have a size of 2, which means we've seen 2 characters, or we've seen a substring of size 2 which has distinct characters in it. So we'll then do the same thing. We'll move the right pointer towards the right, we increment it, and then we'll move, let me move this up, let me make this bigger. We'll move our window again, we increase the size of our window. Our window will have, currently our window will have 3 items, right? We'll have 3 items here, and then we'll still do the same thing until now we found a repeated character, right? Because our window currently has A, B, C, and then A, and we want substring, the longest substring, such that there are no repeated characters, right? So since we've seen so I will increment the window. Since we've seen a repeated character, we need to remove this character from our current substring to build a new substring, right? So we'll move this left pointer towards this point, and moving the left pointer towards that point means we are shrinking the size of our window. Now you can see our window has shrunk in size, right? And the same thing will happen throughout the string, right? You can see we removed this item from the string and then shrunk the size by removing, right? Or when the current characters we have violate the condition that we set, right, we shrink the size of our window, which is what I said here when updates the result whenever the so use the left pointer to contract the window when the condition is violated. So which is what I did here. I contracted the window. Initially our window would have been like this, but I contracted the window by moving the left pointer, right, by moving the left pointer towards B, right, when there was a duplicate of I in our substring, right? So which is the technique we can use to move and shrink, the window around. Now there is another situation. Now in this case, I made a mistake here. So we then need to use set for unique characters, right? So let's say our right now we're looking for unique substring of unique characters in this particular string, right? A substring of unique characters, the longest substring of unique characters. So so far the longest substring we've seen had a length of 3, right? Had a length of 3. But now how do we get the substring? How do we get this? How do we get the unique characters? Well, for us to get the unique character, we need to use how do you call it? We need to use a dictionary to set every unique characters. So let's say we have a dictionary here. A dictionary is also a map, right? A map for finding each unique character. I'll put this as X. So our map will start from here. So we'll add A to the map, right? Let me use a different color. I'll use this color here. Let me use the blue color. So our map is here. I'll call this map, right? Or I'll call this unique, right? So this will be A, right? This will have A. Let me start from the beginning. A is going to be equal to, so we'll increment the amount of time a unique item appeared in the string, right? So I'll do this. I'll say A is going to be equal to 1 at first. A is going to be 1, B is going to be 1 as well, and C is going to be 1, right? So far we have unique string of length 3, right? By simply, to find the length, it's not really hard. We simply need to take the current position of the left pointer, which is going to be equal to 0, and then the right pointer, which is going to be equal to 3 if it was here, if it was at this position here, right? And then so which is going to be 2. Simply do this to calculate the current maximum, the current size of our window, right? So we'll do R minus L, right, which is simply equal to 2 minus 0 minus 0, and since we are counting from 0, we need to add 1 to it to get the current maximum length, which is going to be equal to 3, right? So that's how we find the current maximum. Now we'll use this dictionary to keep track of when to move our left pointer, right? So we know we'll only move our left pointer whenever we see a duplicate, right? A duplicate simply means any character in this string here or in this map having a value of 2, right? So when we see this, right, we simply need to remove the item. But before we remove, right, we need to know by how many we need to increase our left pointer, right? And it's simply going to be by reducing the value of this character here until we remove it, right? Until it reaches 0, and then we remove it from the window, right? Before we introduce a new character in the window. So let me demonstrate what I mean by that. So I'll quickly erase everything here, right? I'll quickly erase everything, go back to the front, right? Let's move to this part here. So I'll show you what I mean by that. So our left and right pointer started from this point, right? Our left and right pointer started from this point. So we want unique items in our window, right? So we'll simply take, so since the right pointer is going to move through the string, right, we'll create our map immediately at this point. So we'll have A at 1, right? We'll set A to 1 first of all. Now we'll then move our right pointer towards the right, by just incrementing it by 1, right, or just using the loop to increment the right pointer. So the right pointer at this point, right, will be at index 1, right? So this is a new character here, right? So this is going to be B at index 1, right? So I mean B occurred one time, right? So this is just to track the occurrence of each character in the string here, which is why I'm using the map. Anyway, so the size of our window would then increase, right? Would then increase like this. I'll put it like this. You know what? Let me represent our window. I mean, this is not bad, right? So the window will have a size like this. Now, what's the size of this window? To calculate the size of the window, we simply need to do this. We simply need to take, the position of our left pointer, which is we need to remove the right pointer, right? How far we've traveled from where we started, right? Minus L, which is equal to 1. The value of the right pointer here is going to be 1 minus 0, right? This is going to be equal to 1. But since we started counting from 0, right, obviously the size of our window is going to be equal to 2, so we need to add 1 to it. Every time we try to calculate the size of the window, even by just removing the position of the left pointer from the right pointer, right, we need to always add 1. So by doing this, right, the size of our window is going to be 2, which means we've seen 2 unique items so far, right? So which is 2 here, and you can see the window has 2 items. So let's continue. Oh god. So let's continue. So we will move the right pointer again. We'll move the right pointer towards this point here. Now when we move it, we will do what again? We'll increase the size of our window, right? And by increasing the size of our window, it also means introduction of a new character, right? A new unique character. So this will also be 1, right? This will also be 1, and then we'll do the same thing again. We'll move this towards this point. Now this time around, we know that our window, we've seen a new character, right? But let's not increase the size of our window yet. So whenever we see a new character, we add it to the this place here, right? The dictionary we have here. So A would then become 2, right? A would then become 2, which means there is an item in the dictionary that has 2 that has been duplicated, right? Because we want every item in the dictionary to have values of 1, or to have size of 1. But since the count of this A here is now equal to 2, what we'll then do is we'll need to shrink our window, right? We'll need to shrink our window. So our window obviously will follow the right pointer wherever it's going, but then we need to shrink it, right? So that we'll have a new window without duplicates, right? So that we'll have a new window without duplicate. So how do we do that? Well, we simply, after adding an item to the window, we simply need to reduce this item or remove it. First of all, we need to reduce it and then remove it from the window, right? So how do we do that? Well, we simply, by reducing, every time we reduce this value, we will need to move the right pointer towards the left pointer towards the right, the left pointer towards the right, and then remove the item, right? So we'll then reduce the value of A by 1. So by reducing this by 1, we'll move this, we'll add 1 to the left pointer, right? We'll add 1 to the left pointer, which means our window has to shrink up to this point here, right? So A then will become 1 again, which means there is only 1 A in our current window, right? And then we'll calculate the size of our window this time around by using the same method, right? So index 0 will be here, this will be at index 0, index 1, index 2, index 3. So we'll do 3 minus 1, which is equal to 2 plus 1. So the size of our window now here is going to be equal to 3, right? And we'll do the same thing over and over again until we reach the end of our string, until this right pointer here reaches the end of the string, and the left pointer is wherever it will be in the string. So with this method, right, by finding the unique string in the array, we first of all, in the string, unique substring in the string, or substring with unique characters are in as part of a larger string, right? We first of all initialize a left and right pointer, right? We first of all initialize a left and right pointer. Where is it? For variables. So use the left and right pointer, right? We expand the window by incrementing the right pointer, right? And then we shrink the window by incrementing the left pointer, right? Because there's a condition that was violated, which is we found a duplicate. But when we find a duplicate, right, it also means that we used a dictionary, right? We use a dictionary to, you can use set, but I'll use dictionary because dictionaries will take less space. So you use a dictionary to find counters or dictionary, whichever, to find the unique items or to keep track. So unique items will occur only once, right? So which means the value of the item in that dictionary should always remain at 1. And this solution, right, this solution is applicable to these other problems. So we found the longest substring, right? Now let's say we want to find let me arrange them. So let's say we want to find the longest substring, right? Where is this question again? Length of the subarray with most k frequency, right? Length of the subarray with most k frequency, right? How many times an item occurred, which is the k frequency in it, right? So with the most k frequency, so they will give us k. K here does not mean the size of the window or the item we are looking for. We're just using k. The length is what we are going to return, right? And we don't know what the length will be, right? So that technique works for this question by just tweaking something small, right? And maximum length substring with 2 occurrences. So this technique also works for this problem as well. So I will show you this. I've actually used the technique to solve these questions and it actually worked. So basically, here's what we need to do. Longest substring without repeating characters. This is my old technique that I used, which is the most efficient. But what I'm showing you is not very efficient, but it works, right? It works by just simply, removing an item. So let's say we are looking for so I'll write out the code again. Let me create the file. Sorry, the file here is 2958. So I'll put it in sliding window 2958 leet-2958 dash, what's the name of the question? You know what, let me do the easier one first with 2 occurrences. In fact, right, because it is easy does not mean it's actually easy, but let's see, 3090, right? 3090. So I'll create a new file called 3090 LEETCODE leet-3090 and the come on, okay. So this question has sorry, what's the title of this question? Maximum length substring. Okay, so max length substring. So I'll say max length substring. So here's our question, and I'm going to use the new method to solve this. So first of all, since the question says given a string s, right, return the maximum length of a substring such that it contains at most 2 occurrences of a character. Now, how do we track how many times a character occurs, right? So I'll copy this, right? Copy and put this here. Now we can see the question is asking us to return the length, the maximum length, right, of a substring such that it contains at most 2 occurrences of each characters. Now we know we only know how many times each character has to occur, right? But we don't know how long the string will be, right? Which automatically means we need to use a left and right pointer and then increase the left and right pointer across the string until a condition is violated. Then we can now shrink the window by increasing the left pointer as well. So our left pointer will start from the beginning. So I'll put this here. I'll say left is going to be equal to 0, and then we need to keep track of unique characters, right? So I'll say count. I'll say character count, right? Character count is going to be equal to a dictionary, right? Now what we'll then do is we'll add each item to the dictionary and count how many times it occurred. So I'll use a for loop. I'll say for I in range the length of the string s, right? Length of string s. So here's what I'll do. I'll first of all find if the character exists in the dictionary or not. So before I increment its value, so I'll say if the character is in the dictionary, if string at I, right? Do I need this I though? I could just use the character straight away, right? Yes, I could do that. I could just say if for character in S, right? If the character is in character count, right? If it's already there, then I'll just say character count for that particular character, and then I'll set it to plus equal 1. Otherwise if it's not there, I'll just set the character count for that character to be equal to 1, right? So yeah, that's all we need to do. Now we'll then use so in this case every character will be inserted and their values will be incremented by 1. So if a character has more than 2, right, more than 2, then we then need to shrink our window. So let's say while a particular character that we found, right, while a particular character in this character string, if this character count here, while the value here, right, is superior to 1, I mean to 2, because we want 2, right? We want 2. Then we will then shrink the window, right? Because that item has occurred twice, so we'll shrink it past how many times it occurred. So I'll do this. I'll say first of all, we want to reduce the value of that string, right? So we'll say character count for that particular character, right, for that particular character, minus equal 1, right? And then we know we are going to shrink our window anyway. We are going to shrink our window by moving the left pointer, right? So we'll say oh come on, we'll say left pointer plus equal 1, right? Now by doing this, right, we increment the left pointer. So we want to do something else. We need a condition where we need to stop incrementing this character, right? I mean, when we find if the value of the character is superior to 2, right, because we want 2 occurrence for each character, we then reduce that particular value at that point. So let's say, for instance, we have here's a string here, right? B, C. Let me copy this string here. I'll put this here. They are not the same, so let me just put this here. Come on. Okay, so let's say our window is like this, right? I mean, our string is this, and then we start creating our map, right? I'll put B here. B is incremented by 1. C is going to be 1, right? And then we find another B again, right? Because we find another B, we can increment this to 2, because every item in the string has to occur at least 3 times. I mean 2 times twice, right? So we want 2 at most for the occurrence of each item. So when we find another B, then we'll increment this by 1, right? We'll increment this by 1, and the value at this point here will be at this point. So will be at this point. So our right pointer will be here, our left pointer will be here, right? So but when we move to this point here, this will become 3, and we don't want 3 in our string, right? We don't want 3 in our string. So what do? We then get this item here, right? This character here, and then we reduce its value down to the condition where we are asked to reduce it to, right? So we'll reduce it to up to, what is the question again? We reduce it, oh god, we reduce it up to 2, right? Up to 2. So once the character is superior to 2, we reduce it up to 2. But there is something else we need to do. After reducing it up to 2, right, we need to, when that value is reduced down to 2, right, so let's say, oh god, when that value is reduced down to 2, we need to remove it from the dictionary. We need to remove it from the dictionary so that we can have a new one, right? We can have a new one with a single occurrence, because our left pointer would have moved to this point. Our left pointer would have shrunk all the way to this point here, right? Okay, our left pointer would have shrunk all the way, so it will increment by 1, 2, right? By 1, 2, so, and then 3 right here. So our left pointer will be here, right, since we are removing every duplicate and we are starting out fresh. So now our new string is going to continue from here upward, from here forward, oh god, from here towards here until we meet another duplicate again. But every time we see a duplicate, right, every time we increment our right pointer, we always calculate the maximum at that point, right? So yeah, so that's what we need to do. I already have the solution here, but I'm just trying to do it again so that you see how it is done. You can see if the character count is, of the left is superior to 0, then, I mean, if the character count of the left is equal to 0, then we remove it from the dictionary, right? But in this case, we are not going to have less than 0, so we'll increment by a certain amount and then move the left counter towards that point. So let's see. Oh, sorry, I got carried away. So there's a mistake I made here. I need to take the character here, right? So the character at this point, instead of doing character at character here, right, I need to say character at the left pointer, because that's where you know, I'm not sure if I should use character. I think I still need to use the left and right pointer. Yes, I need to use the left and right pointer still. So let me remove all of this. I'll remove up to this point. I'll say right. The right pointer is going to be for right in S, right. Oh, in range the length of the length of the string, length of the string S, right. Length of the string S. If this the let's say S at right, S at right is in the dictionary character count, right. I'll just say increment the value of the character count at S right. This is so much words. S right by 1 plus equal 1. Otherwise we just add that value to the character count at S right to be equal to 1. Okay, so that's all we need to do, and then we'll run a while loop whenever we find a duplicate. Right now you can see when the character is already in the string, right. So when the character at this position is already in the string, is already in the dictionary, and its value is superior to, because we want maximum occurrence to be equal to 2, right. So we'll say while the character count in the string right superior to 2, right, we'll then take the character. We know the duplicate will only occur to values we've seen before, right, to values we've seen before. So if we were here when the duplicate occurred, right, so we have our left and right pointers here, and then we'll move the right pointer through the string, right. We started like this, so we'll move to this point, and then this point. This will become 2, which is fine. But when we reach here, right, this becomes 3. So we need to reduce, and when we reduce, we will just simply move our left pointer to this point here, right. So meaning we are removing the last occurrence of that particular item from the string, right. We are removing it from the string. And if it was another character that was repeated, the same thing will happen. We'll shrink the window by just incrementing the left pointer like I did here. So you can see if the character nums at left, which is the left pointer, we reduce it by 1, right, increment our left pointer. Now this is just an edge case here that let's say we reduce a character up to a point where there's nothing else to remove, then we simply delete it from the string, right. We simply delete that particular character from the dictionary, sorry. So we'll say while the character is here, so let's say so character count in the dictionary, right, character count, so this is going to be S at left, right, left. We'll then reduce by 1 minus 1. So this is going to be minus 1. This is going to be left minus 1, right, and then we'll increment our left counter by 1. So left plus equal 1. Now, this is what we need to do ideally, but there's going to be a case where we reduce an item more than it occurred, right? So if that item, so I'll say if we reduce an item before we even increment the left pointer, right? If we reduce an item more than it occurred, right? Because we're going to iterate through the how do you call it, through the dictionary count to increment the left pointer. So if it happened that we reduce an item more than it occurred, right? So we simply need to let's say 0, right? We simply need to remove the item. So they'll delete the character at this position here, and then increment the left counter by 1, right? So, and every time we need to find the current maximum, right? So we'll simply do maximum here. So we need maximum here again, because we are finding the maximum length, right? So I'll say max length is simply going to be equal to 0 at first. I'll set it to 0, and then when we start calculating, right, I'll say max length is simply going to be equal to the maximum between max length and the current character we have. So it's going to be left. We do right minus left plus 1, and then at the end of the day we return the maximum length here, max length, like this. Now, this will not be the best solution in terms of time complexity, because we have this while loop here, right? But this will work. Let me just show that to you now. I'll copy this, and where's the question again? With 2 occurrences. So yeah, I mean, the idea is to understand how these things work before we begin to optimize our solution, right? So let's run this again. Let's run this solution. Now you can see it worked just fine, right? Because I mean, we returned 4 for the maximum substring with just 2 characters repeating, right? So this worked, right? Now we know how many characters have repeated, right? Which is 2. When I submit this, I already did before. I don't know why it's not showing. Oh my god, LEETCODE has a maintenance thing to do today. So now you can see this worked just fine, right? This worked just fine, which is not really bad. But this solution is also applicable to other questions, right? If you look at this, I use the same technique to solve this question, which is a medium level question, because I already understood how it worked, right? So simply, instead of finding 2 occurrences of each character, right, we are going to find occurrences of k characters, right? You are given an array nums, right, and an integer k. The frequency of an element x is the number of times it occurs in the array, right? An array is called good if the frequency of each element in the array is less than or equal to k. Now, instead of using 0 as our k, so our k here in this case represents 0, right? So this solution here also worked for this question here. As you can see, we are simply shrinking our window for every character in the count. I mean, for every character in the dictionary that is superior to k, because we want our value to be less than or equal to k. So whenever we see a value that is not k, right, that is more than k, right, then we simply need to iterate through the dictionary and reduce their values, right? And every time we reduce a particular value, right, we need to increment the left pointer, right? We need to increment the left pointer, and which also means we are incrementing to the next value, again, which is simply the same as this one here, right? When I run this, although this is a medium level question, but because I recognize the pattern, right, I was able to solve this. I can see this also worked, but again, it is not the best solution, but it works, right? It works for this solution. It works just fine. It is not bad yet, right? I mean, the runtime was really long because the test cases were probably long. We are using an array here, so which also means it's taking a lot of memory. But this works. This works for this solution, and it will work for this longest substring without repeating characters, right? We know this time around our k will simply be equal to 0, right? So I mean our k will simply be equal to 1, right? And if any value is more than 1, then we'll return 0. So I'll take this, right? Just watch. I'll copy this solution here, although I've solved this question before, right? But this solution requires more steps to understand, which is why I came up with this simpler one, right? This is more simple and easy to understand, right? So whenever we find an item, we simply iterate. But this time around, we are not using k, but we are going to use superior to 1. And if you see, when I run this question here, when I run this solution here, it will work. Sorry, we don't use nums here. We are using s instead of nums. So although, okay, let me just go to my previous submissions because I already solved this with the same solution. Sorry, this is not the same. Yeah, so this is the same solution, the same submission. I'll show you the code. So here's the code for it, which is simply similar, right? It's the same thing. It's almost, I can't post anything here. Let's see. I can't post. So I mean, it's similar to the same question. I'll just copy. No, this wasn't what I wanted. I used the set in this one. Let's see. Come on, show me my submission now. 2 hours ago. Let me see the submission here. Oh, come on. Oh god, I've closed my editorial. I use this while loop here, which is really, you know what, let me just write this out again without using the nums. Instead I'll use s because we are using string to check. Instead of use, okay, the thing is here, come on, okay, I can see the solution here. All right, so let me just copy this, right, and run this again. Now this might shock you a little, but let's keep calm. I'm going to remove all of this, right? So instead of using, okay, so I was using any, which is really bad for our solution. So I'll just say the character here, right? If a character here has a value superior to superior to 1, right? So this is what's going to happen. So let's run this again. And you can see this has passed the test cases. I mean, in terms of submission, there were higher test cases, but it did well in terms of memory, but runtime not so good. But yeah, but this is to just explain that when you recognize a certain pattern, you can use the same solution to solve it. And I'll push this to GitHub for you to see this note and use it in your questions, in your forthcoming or any problem you see. I'll do more research on sliding window to provide more insight on, or more tips and tricks like this one here. So let me just go ahead and submit this, right? How many questions did I solve? I solved 2, right? I solved 2. Longest substring without repeating characters. This worked. Which one is this? longest K frequency. So this 2958, I will post this on GitHub. I will submit this to GitHub as well. Let me move this here. 2958. So this dash 292.958. Come on, 58. And it's going to be length of longest. Oh, come on. Let me just do it here. Let me move this to this side and this here. So 2958 leet 2958 dash len. I'll copy this. I'll say maximum subarray length. Oh, with most K frequency. Max sub array len with most K. I hope this is not too long for a file name. Okay, that is good. So I'll put this here. Right, I'll copy the solution here. It's easy, it's simple. It is not the best, but it works. So so this will help us appreciate the optimized version of the solutions. So I'll copy this, right? Copy this, and I'll push this to GitHub. So by saying git add git commits, so you have it with the tips here for sliding window git commits -m, and I'll put this here. And then there was LEETCODE for LEET 3090. I'll just leave it like that. So I'll say git push origin main. Okay, so this has been pushed to GitHub. You can have access to this question on GitHub. Alright, so that's it for this session. 2 questions solved. Very good. Just know you can memorize this. It works, right? It works. Even in the worst case solution, it still works. So simply iterate through, whenever, for every character that has a value superior to K, right, which is this while. So it will start from that particular point, right, and iterate through the string, and we'll increment the value of our left pointer by 1, but then we will need to remove 1 from the value from the first string, right, and then just because we want to push our left pointer towards shrink the window towards where there is no violation of this condition here. So yeah, so this is it. You can take a look and understand it, right? Anyways, that's it for tonight, and